Fine.
That's kind of a bummer.
Fine.
Okay.
If you go to YouTube, I think you're like
Dave Bransky, can you nod or something if you can hear and see me?
Yep, we can hear you and see you.
up on the screen. He's not connected to that.
We're working on it, you guys. Technical issues, hopefully resolved soon.
I have not been at Macomb in how many years now? I may not come back.
Which is strange because we never have these problems.
Right.
Yeah, never. There we go.
Okay. Yeah,
We are live.
okay. Well,
Check with Dave if he can hear you.
Dave, you can hear and see, right?
Yes, I can hear and see you, Dale.
Okay, thank you.
We can hear him through the speaker.
Yeah, we can hear you too. Okay. Slightly belatedly, but with many thanks to Dale Teamy for getting this show on the road. This is the Warren Astronomical Society. Hello, everyone. Bob Tremblay, our president, who is normally doing what I'm doing right now, is away, I think on a vacation.
Mhm.
And so as the first vice president, it's my job to fill in for him. Let's start with officer reports. Bob's not here to speak for himself. I think he would announce or re-announce that the club picnic, our summer picnic, is on Saturday, August 24th, not in July. I think that's the fourth Saturday in August, our normal time for having an open house. That's the day of the club picnic.
But not the normal time.
Yeah, what is the normal time? I can't remember.
For the open house, sunset, but for the picnic, I think what?
See, it's 4 or 4:30.
Yeah,
Yeah,
let's just say 4:30.
something like 4:30, the picnic will start.
I'll change the newsletter for that then.
Okay.
Bring,
Is there a sign-up sheet?
No, you just come.
but please bring
Yeah.
a side dish.
Bring
Bring
something fast.
Yeah, we'll be having more details as time goes on, but I'm sure the club will be providing stuff like hot dogs and hamburgers and that kind of thing. So my normal report will say I'm always looking for speakers. I'm actually filling in. Bob's wife Connie was going to be speaking this evening, and then something changed with their vacation schedule. So the presentation you're going to hear, I just finished about an hour ago. I have worked on it for 2 days, most of the time. Anyhow, we're booked almost through the end of this year. We're now going to be mostly looking for people to give talks starting in January and going forward from there. So if you have something in mind, it'd be helpful to me if you let me know. Either for a full-length presentation or a short presentation. Okay, our second vice president, Riyadh, you want to come up and speak?
Thank you. Hello, everyone. Last open house was on June 29th. And unfortunately, it was clouded, although we did have about 5 or 6 people that showed up. We talked about astronomy, about the club, about observing in different telescopes. So we still made something good out of being out there. The next open house is not this Saturday, but next Saturday, July 27th. So hopefully we'll have a better night. But come on out if you can, unless the weather is really bad. Come on out and we can sit and chit chat. And of course, if it's clear, we have a lot of great new equipment also to look through, to observe, and to use. August, as was mentioned, August 10th is the picnic. And then, I'm sorry, August 24th is the picnic. But August 10th, we have an open house for the Perseid meteor shower. So don't forget that. Don't forget to bring out chairs, blankets, whatever, so you can sit, relax out on the field. And of course, if it's clear, obviously we'll also have the telescope running. So Perseid's on the 10th and picnic is on the 24th of August.
Was there a question?
The Perseid.
Yeah.
10th.
The
August
10th,
10th.
August 10th. Okay, that's all I have. Thank you.
Okay, thank you, Riyadh. David, would you like to give your treasures report?
Sure. So in our checking account, we've got $25,497.42. In our PayPal account, we got $398.67 in there. There's nothing due on our credit card. I did order up a book of checks since the dome was repaired, and the board had wanted to send the gentleman a check of $500. So I've got a checkbook so I can write that. So that'll probably go out sometime this weekend. So that's it.
Okay, thank you. Outreach, Mr. McLeod.
Just backpedaling a little bit, if you had not heard, Riyadh found an angel, came to him in a dream, and this individual was able to they repaired our gear reduction drive that had been plaguing our motor that actually spins the dome. So the dome is actually fully motorized again. So that's what David is referring to when we fixed the dome. So that's been a long time in the making.
Yeah.
So I'm super stoked about that. We don't need a dome kit, which is crazy. We never got one, but
Is that automated to the telescope?
no. If you would like to write a Python script, okay.
I thought I heard a volunteer.
No, it's always fallen under the category of not quite worth it. Not quite worth it. There's a nice simple forward reverse. So outreach, I got nothing. Mark Kedzier is going to take care of Memphis Library in early August for me. Nothing else on the books except for we have some other stuff going on in August. So we've got the Perseids at Stargate. The Metro Park is planning something in August. We'll get details out to you the closer it gets, whether you want to just come out to the event or help us. It's some music concert, but it has an astronomical theme. So they kind of just want us as a gimmick. So we'll trick people into looking through telescopes. And then obviously astronomy at the beach after that, but it's out just far enough where you don't have to start panicking yet, but I have to start thinking about logistics for getting the big dob. If you would like to run the big dob at astronomy at the beach, let me or Riyadh know. We will get you spun up at one of the open houses, and then you'll be ready to go for astronomy at the beach. That would really help us out. It's nice to have 4 or 5 people over the 2 days so that one person doesn't have to go up and down that ladder 1,000 times. I'm giving a talk on tides next month at Cranbrook. Tides. You thought you knew them. You don't. And I'm going to try to bring the spaceship to the open house, weather dependent. So that's all I got.
Astronomy at the beach again?
20th and 21st of September, I believe. Is that a Friday, Saturday? Yeah, 20th and 21st of September.
I thought it was 21 and 22.
Is that Friday, Saturday?
Sunday.
Yeah, no,
Whichever one of those is Friday.
it's Friday, Saturday. I think it's 2021. And that's not at the normal location. So be advised, don't drive to Island Lake. It's Mayberry State Park. Never been. Well, your guess is as good as mine. I'm sure it's fine.
Okay. Thanks, Jeff.
Yep.
Hello, Mike. So I don't see Charlie Strackbine here. Is he online?
Nope,
Okay.
don't see him there either.
Okay, well, he's our secretary, and if you want to know about what's going on, the minutes are in the WASP. And Vatshalya, is she online? Okay. She's in charge of publications, but our editor, Dale Teamy, is right here, and I'm sure he will tell us that the WASP
Is online.
is online. Okay. So normally, near the beginning of the meeting, we do introductions. I held off a few minutes for people who came in a little late.
Thank you, Dale.
So let's go around the room. I'm Dale Partin, first vice president.
Dale Teamy, editor.
Dale Hollenbaum, the last of the Dales for tonight. Regular member.
Okay.
Team one, paid member.
Jeff McClellan. Bob Berta. Angelo DiDonato. Ken Ward.
Yeah, Matthew, Sonny Spilos is checking everything out, and the same ones all about it. It's quite tough stuff.
Cool.
What did you say your name was?
Sonny Spilos.
Okay, is this your first time here?
First time, I caught you online, and I registered for the email, and I took your hand.
So,
Thank you.
yeah, welcome. How did you hear about us?
I looked at astronomy clubs on Google,
Okay,
and you were right in Warren, close to Harrison Township.
yeah,
No brainer.
yeah.
Okay, telescope.
Celestron 8 SE.
Oh, those are the ones everyone wants.
Yeah, Celestron 8-inch SE, nice.
Yeah, it's a bit to lug around, but boy, when you get that thing on the moon.
So
Yeah,
we'll see you next Saturday.
Dad, I'm gonna be out of town.
Oh.
I'm just getting, I'm just feeling you guys out, see what it's all about.
okay, well, welcome.
Thank you.
If people who are online, that was everybody here, right? Tina, did you introduce yourself saying paid member?
We got her.
I was a party crasher for many months.
Okay.
I wanted to make sure I paid.
I'll look for you for advice.
Try before you
There's
buy.
not much.
Well, one thing is, under our club rules, if you join in the second half of the year, which we're in now, your membership, you pay 1 year's membership and it's good through the end of next year.
Okay.
Oh, right now, you're a year and a half, yeah.
Yeah, so right now you'd get effectively a year and a half
Okay.
for the price of 1 year. So would the people online like to introduce yourselves? Anybody who would, feel free.
We're all muted.
David Baranski,
Yeah,
treasurer.
Okay,
Well, there's Alan and Cheryl.
Alan and Cheryl Kaplan.
okay.
Dave Bransky. People are just jumping around now.
I saw someone in the chat there. Looks like someone new, perhaps.
Allison Bentley. Kelly Trudeau. Cheryl Dunifer. Yep.
Jerry Dunifer.
Somebody named Mike. Victor Mansky. That covers it.
Okay,
Jerry.
Yes, oh, I'm not there. There I am.
There you are.
Yeah, I'm here.
all right. Well, welcome everyone who's with us online.
Ask Jerry where I can get one of those globes.
This is a Farquhar globe, which I bought about 50 years ago. Farquhar, I don't know if they're still available or not. One can try looking them up online.
I thought it was a bingo tumbler.
I can find cheap.
Okay. So we already talked about the club picnic is August 24th, starting at 4:30. And astronomy at the beach is either September 20 and 21 or 21 and 22, Friday, Saturday, at Mayberry State Park.
Is it actually both?
It's always Friday and Saturday. Is David Levy online?
I haven't seen them.
Okay. Okay. So let's do astronomy in the news. Has there been any astronomy news lately? Yes, Bob.
Yeah, the big news is 2 days ago.
Why don't you come up here so the online people can hear you?
There we go. This one or that one?
Right where you are.
Okay. The big news is as of 2 days ago, Meade telescopes, Orion telescopes, and Coronado are now defunct. The only remaining mass, I guess you might say, telescope company is Celestron, and then Skywatcher in Canada. And Celestron and Skywatcher are pretty much one and the same. They're owned by Cinta. If you go onto YouTube, there's a whole convoluted explanation of what went wrong and everything, but it would take more time than we got today to discuss all the ins and outs. But the bad news is Meade Coronado makes H alpha scopes, and Orion are gone. There is still an H alpha company, so we're saved there. But unfortunately, we're not going to have the competition to keep the prices down, so that's not good. So they say that the intellectual value of especially Meade is something that's valuable, so they suspect somebody will come along and buy them, but just for that. So that's where it stands now. Pardon?
Will it be Celestron?
I don't know. Probably at this point, probably not. Anyway, so if you want more information, I think if you go onto YouTube, you can find it. Just look on there about Celestron breakup. I don't know what the actual link is, but that's where I saw it, the explanation of what happened there. And also, I saw somewhere else a couple of people were posting about it. It may also be on the Michigan Astronomy site. I haven't looked there, but there might be something on it there. Anyway, not good news.
Okay.
If you've got 40 grand, you can get a Michigan-made planewave. I think their smallest telescope they make now is like a 28. They're massive. They stopped making their small ones. Maybe 18 is their smallest, or 19. 19.
CDK 20, 17,
Something like
they don't
that.
make the
Yeah.
17 or 14.
20
There's a discussion going on about Planewave, which makes telescopes near Adrian,
They
Michigan.
have an open house in October. I'll tell you about it later.
I got a little bit of common news. So I had just read that there's a comet that on July 20th is going to have its closest approach to Earth. Comet 13P Olbers. I don't think I've imaged this one. It is in the northern hemisphere right now, visible just after sunset. I'm looking here. On the 20th, it's going to be closer to Earth, not necessarily closer to the sun. Latest observed magnitude is 6.9. In between Leo Major and Ursa Major. And, I don't know what quadrant of the sky that is right now, but so that'd be a good one to check out. If we can do it.
Thank you. Thank you, Dale. Anybody else? Anybody online? Any astronomy news? The only thing I can think of, sort of tangential to astronomy, is SpaceX had a Falcon 9 rocket not perform correctly. Had a propellant leak, I guess, on the second stage. And things didn't go well. That's the first time they've had something like this for a long, long time. So that's going to delay some space missions. I think they're in a pause period while they work on trying to assess what happened and how to fix it. Certainly there will be no human crewed missions using that rocket until this is very well resolved.
Aren't there also some up there that are stranded up there also that supposed to come back?
Well, it was supposed to launch a bunch of these Starlink satellites, and it put them in too low of an orbit because I guess it ran out of propellant. And they were trying to get those, they were at an altitude where the Earth's atmospheric drag was substantial. They were trying to overcome that. I didn't hear whether any of them managed to get up into orbit or not.
But also the point was there's people on the space station.
Yes.
And they're stranded there until they get somebody over there to get back. Starlight.
Yeah, the United, that's the United Launch Alliance rocket. That's the United Launch Alliance rocket.
Yeah, Starlight, they're both Starlight.
Yeah.
And then the capsule. Yeah.
Anyhow, the Starliner, which took 2 astronauts up to the space station, has been docked to it way longer than it was planned to be, and I don't think they know yet when they're going to come back. Well, some problem with some of the thrusters, I guess. So, yeah. I mean, it's amazing how these two ships that were supposed to be able to transport people to and from, both are temporarily out of action. Yeah, it would be ironic if we had to use a Soyuz to get people down. Okay, so that's some astronomy news. Any astronomy observations anyone has made lately? And after this, by the way, we're going to have astronomy questions. So if you have a question, including our new visitor, be thinking of your question.
In connection with the,
Why don't you come here so that they can hear you?
I think well, okay.
Or you want me to
I'm
repeat
reading
it?
off the screen here.
Just do it loud.
Yeah, Allison Bentley says that her club is scrambling to get others for the library programs. It's a big topic in New Hampshire. That's where those library telescopes originated, the
Yeah.
idea for that.
Yeah.
And there's a big scramble now to find a library, because Orion was the telescope, to go to a telescope for the library telescope program.
Okay, what Dale Teamy is saying
They're going
is
with Zoomel while they can.
you're going to what?
So they're going with Zoomel while they can? Zoomel, yeah.
Anyhow, a lot of libraries in some parts of the country have started acquiring and loaning out telescopes. And in fact, we gave such a telescope to the Ray Township Library, since our observatory is, you can almost see it from the library. And if the company that made the most popular telescope for this purpose is going out of business, then where are we going to get telescopes?
Yeah.
And probably replacement parts.
What's the last one makes a similar scope. There's a number of competitors.
Yeah.
So,
Yeah.
but
One less.
that's right.
Star Blast, 4.5 inch, I think, was what they liked.
Yeah.
Was Orion. Right.
Yeah.
She goes on, we had an order for 7 scopes that disappeared. Orion has not responded.
They had scopes disappear.
Well, they had an order
They
for
had an
7
order.
scopes. The
Oh.
orders,
A library in New Hampshire ordered several of them, and they haven't come.
right, did not respond.
Yeah, if somebody goes bankrupt, they can keep your money. Right? That means their debt is erased. Depending on the type of bankruptcy.
Yeah.
I've been in a company that went through bankruptcy, and oh man, what a mess. Okay, any other astronomy related observations? Anybody have an astronomy question? These are sometimes kind of fun if we get one.
Are there going to be more clear nights this year?
Are there going to be any more clear nights this year?
I got the telescope a couple of months ago, and I got one clear night, and I set it up at the house, and then every night's been good.
Yeah.
That's your fault.
All those Canadians,
Are they burning things again?
So we're having a discussion about how there haven't exactly been a lot of clear nights here in Southeast Michigan for a while.
Clear last night.
Any other astronomy questions? Yeah.
The upcoming NOVA, when's the time frame? Is it August, September?
Yeah, it's late summer. I don't know if they actually can narrow it down.
Talking about when the next NOVA is?
There's a episodic nova that is theorized to be going off sometime in late summer, but I don't know if they.
Yeah.
Yeah.
There
yeah.
Or yeah, there you go, Como Borealis. You said when
Yeah.
it goes on, give or take a few months, right?
I feel like I
Old
looked it up
Faithful
and it was that was something else. I don't know. I don't. What do you know? What the expected magnitude is?
Someone said Polaris.
Oh, it's not bad.
The discussion that concerns a prediction that a particular star is going to go nova, which it historically, I guess, has done periodically.
Yeah.
And somebody thinks it could become as bright as Polaris, and it could happen within the next month or two or something. Okay. That would be kind of neat. Now, if only we had a magnitude 1 comet that hung over the northern hemisphere for a month, that would get a lot of people excited into astronomy. Okay. So it's now about, I'm hearing an echo. It's now about 7:30. Let's take a 20-minute break and come back at 7:50, 10 minutes to 8. Okay? See you soon.
Yeah. Would we have time to show a couple of pictures sometime today, a couple of recent astro photos I got?
Sure. Should have told me.
Computer.
Yeah.
Is it just a slideshow or are you going to talk about it?
No, I would talk.
Oh.
This is for after the break, I guess.
Yeah, we can do that.
Any time between now and September.
It's for that NOVA.
Sure.
It's not a supernova, right?
There's no virus on there, right? Pardon? There's no virus on there, right?
Last time I looked, it didn't have one.
So
Right enough to magnitude 10.
So
yeah, it's episodic, so it's yeah.
So a supernova is once and done. It's a destruction.
Yeah.
And nova is a brightening.
I don't know if novas are necessarily just. I think there are still novas that are one and done.
Okay.
Like type 1A is. Well, 1A is also you have a white.
You know what I'm thinking about doing?
Or you have a star deposited into a.
Think about setting up one of my telescope rigs.
Yeah.
Turning it into one of those. Down in Texas, started by a guy I follow on Astronomy.
I mean, eventually it's gotta run out of that stuff, so it can't go on forever.
He has several roll-off roof observatories.
I guess it's not,
Two-ish.
if it's not enough to
Of course, the math
last
looks like
away
two, but
the other stuff.
$145 a month. That's way cheaper than other ones are like $600 to $1,000, $600-800.
Yeah, what I looked at.
But these are meant for smaller telescopes The one I will send, I think is $199.
Yeah.
My 80mm refractor.
Yeah.
I've been using my little red cat, which I like. But my 80mm. Problem is, I use ASI here for everything.
Yeah.
I think it'll work as well.
Yeah,
I would do
I think
Windows.
there they have to use.
Known as a
They say you can use ASI air, but I just think for that, I would want.
binary system, a red giant and a white dwarf
I wanna learn
orbiting each other
something.
every 228 days.
Yeah.
Go
The
through
biggest
Windows.
problem for the mobile observatory, you need somebody who can come by and kick it.
Less
They
than a
need to
dozen
call
of
us
those
and say,
type
hey,
notes.
something's not working, can you check the wire?
It's included.
Oh, it's included, okay, that's it.
It said 80
You
years.
just send him a message,
Yeah.
clean the dust.
Yeah.
Reboot. Actually, I'm gonna have power, I can remotely reboot anything.
Yeah.
I had no idea what
I'm thinking more in terms of something that gets bad wire or whatever.
I'm gonna get something that closes
Yeah.
for a flat cap, so I need to buy some.
Yeah.
If anybody's interested, there's pie up there.
What kind?
Yeah.
Apple.
My boss gave it to me and I'm like, what am I gonna do with?
Well, then it's different.
Yeah.
I mean, come on now.
That's
My
what they're
double
saying,
chin,
yeah.
it's paid for and I can take it with me. but come on now.
Close enough to look like that.
That looks good.
That generated some interest.
Be close enough.
Yeah.
Again, be close enough.
I don't know,
Now it's just September.
the next year.
Now,
Like,
I feel like that's a constellation I have.
it's a learning curve.
Oh, yeah. You don't want to be, yes.
Yeah.
South, and right now, at my house, where my telescopes are, I can't see south.
So I can see the top is great when it's over the
Well, that's probably the south is bright.
Oh, I'm sure you did.
But I'm in the thumb,
Summer stars.
but I got a tree map. I can, you know, I got M16 the other night, for a total, I think, 14 minutes before I hit the trees. And how many months do I have to do to get a decent image of M16 for that?
So you can't rent a chainsaw?
Yeah, think about it.
Oh, I discussed it with my wife. She has taken it under advice.
So don't get back to
Yeah.
Right.
You don't have to do
Improving my southern
You only joined the
exposure.
Yeah, of course.
Right, okay.
Yeah. I have one of those.
We finally got it.
backyard. I'd like to get rid of it.
Oh, also, if you guys have made of money, the Willow Run Air Show, Thunder over Michigan, is this weekend.
It's expensive, what is it?
It's like $70 for general admission, $55 for parking, or if you want a tailgate, $200.
It's 180. I got it.
Yeah.
It's up to 6 people in your car. We're taking 5. So
Near Ann Arbor.
it's not terrible.
Nope, no, I found out about it way too late.
Unfortunately, there's no like real big acts because next week is Oshkosh, which is like the biggest one in the country.
That's what going to Wisconsin.
So no Thunderbirds, no Blue Angels.
Oh, really?
Beach.
Who else isn't gonna be there? No snowbirds.
They had some P-51s though, it looked like.
No, my boss gave it to me as I
Those
was
are
walking
nice.
out the
Yeah,
door.
absolutely.
Client brought it in and right now it's just me. I can't-
So there's new stuff.
So I
It was the
figured
first
I'd
thing that
come
came
in,
up when I
share
started
with you
Googling
guys.
it.
So how's your wife doing? Tell her I said hi.
So, yeah, tomorrow night, is the press, my friend's going, and I'm going
Jefferson
Saturday.
got closed off the day of the
Yeah.
air show, so.
It is one of the more expensive ones. It's not a good value. But if you get enough people in the car, bring a minivan. So I'm splitting it 5 ways, 180 bucks.
Oh, yeah. So do you have a lot of gatherings through the year as far as bringing scopes and everything together?
We're at our observatory.
So, do you know where our observatory is? Okay, you're over at Harrison, you said?
Well, I guess the orchard is on 32 Mile Road in Van Dyke. Morellan? Yeah, it's Morellan. This
Right
pine
by
comes in
the
and
fire station, that's where
Hi.
we're there the fourth Saturday of every month.
Wow.
Unless it is like,
Open house for free?
unless it is like torrential rain. And
Okay.
even if it's cloudy, we go out just to see who's gonna show up. And then,
Okay.
no one shows up.
Yeah,
we pack it in. But
right.
Riyadh, I mean, if it's a good night, he'll be out there till 2, 3 in the morning, looking at double stars. Can't stop him.
Okay.
And club members bring their scopes. Some people, he's doing photos and stuff, and other people are doing stuff with kids, and it's a great time.
A couple months ago, we had 12 scopes.
Yeah.
That's a good.
Oh,
That
there's
was a
been-
really good night.
Before COVID, there were times where like the pros would line up on one area. We'd have like 6 just monster scopes, and then there'd be another just 10 kind of, scopes like that. Manuals, twist the knob kind of scopes.
There's something to be said about
I love
those.
them. I love them.
It was
I know. $200. Can't beat it. It was a good time. And then we're trying to get into doing more one-offs. So like Rhea put together this thing for the Perseids. We try to do something for the Perseids every year.
Okay.
But if we can get some interest, it'd be cool to have like a members night where there's not going to be just people from the public who want to come out. We can do something a little bit more dedicated. Like, we've got I always forget this. I think it's an 8-inch refractor, right? 8 10 8-inch. We have an 8-inch refractor, just monster under the dome, and then we have a 22-inch Sony in the shed that we pull out. And those scopes are for club members to use. It's just you gotta get geared up on them and know how to run them and this and that. And so, if we did more kind of members nights where you don't have to worry about we're doing this, we're trying to do that. It's like you got a camera. You want to hook it up to one of our scopes,
Well, something.
we don't have a lot of it, but we're trying to invigorate more people to use what we have.
Oh, yeah.
We got some really cool stuff. A couple months ago, probably 6 or 8 years ago now, we bought
I think he bought a used.
oh boy, I'm having these cognitive issues these days.
Cognitive issues.
It's happening.
Tell me about
It's
it.
happening more and more.
Are you 50 yet?
No, fast approaching 40.
You're younger than I thought. Your check engine light goes off.
Much like spectrograph. Oh, put into our eyepiece, and you can actually, it produces data. Like if you look through the eyepiece, you just see rainbow. But you can actually get data off. I don't think anyone of us have done it yet. We have like a really cool reticle eyepiece that you can measure separations with. So like if are you familiar with Astronomical League at all?
No.
So Astronomical League is a international, national, at least national, like organization. You can get a membership through us for $90, I believe, and they send a quarterly magazine, and they have observing programs. So you can go on their website, and they have like a lunar program, a Messier program, a satellite program. You just log your observations, then you get these cool pins. I always wanted to do at least the lunar program. I always started and never finished it. But so they have cool stuff like that, where maybe you don't have the equipment to do one of these things, but partner with us and you can do some of that stuff.
Yeah, I just like to, basically, I just bought the thing a few months ago, and I just been running it, gunning it.
Yeah.
I haven't had a night where I could start, programming the thing, selecting the
Are
three
you trying,
stars.
are you a visual guy or are you trying to photographer?
Oh, I'm just visual. I like live because
Then me and Riyadh are your guys. We're the visual.
Yeah.
He's a photographer. Bob there, big time. I mean, these guys are. They put space telescopes to shame sometimes.
really,
You've got this one too. What is it, an image in the calendar? Yeah.
Well, the biggest one right now is all the semiconductor.
Does anyone remember what the calendar is this month? Do you know what the image of the calendar is this month?
I think I think
No, you got two. Yeah, you got two.
both the wasp. Wasp Meister.
So I'm reading our newsletter. We do a calendar every year, and it's all club numbers, and I mean, they're really amazing. We should really find a way to get it out to more people, because I feel like it rivals.
Oh, we had $25,000. We could have just print them and give them out. I mean,
So you can't give it away, then people don't think it's worth anything.
there's something to that.
You gotta charge, you got $50 and something.
So the space at Wilcott is just like you have your telescope in that park, and where do you have like a building you own on?
Yeah, so we have an agreement with the Metro Park, because we actually predate Metro Park. We were there when it was actually owned by the Macomb Club. So that, the building that we have was built in 1970. Or actually,
That was Marty's.
might even been
What was?
just before the building. No, the club was just before the building. The building was just set. And so we own the building. No, sorry, we own the roof, the dome, the telescope. They own the building.
Okay,
We control the inside of it. They manage everything on the outside.
all right.
And we're allowed to be there. So if you're a member of the club, you can actually be at that park after hours. Like if we're not there, you can have your telescope set up on the field. The local Metro Park cops might, say, hey, what's going on? And say, member of the astronomy club, we'll get you a badge.
Mhm.
And they're like, oh, yeah, you're fine.
Sounds great.
They have an area probably the size of like 2 football fields, more or less.
Good.
So I mean, you got a good separation to the trees. And the stargate's more or less in the middle of
And
that.
if you're there by yourself, you'll be able to park yourself in a spot where there's the least amount of stray lights coming in, because the park does have some lights that we try to mitigate when we're out there.
Right.
We're working on getting solutions to more of them. When we have.
And then told him I was run by the
We don't usually worry about it too much, but,
He was all for it.
Yeah, I never set up in the shadow of the Stargate.
yeah, that's the place to be.
It is. Well, I should let the visual guys go over there. But yeah,
There's plenty of shit to go around.
I have a power pole in my yard, so it's how I like.
So you're
So I'm
used to
doing
it.
it.
Yeah.
Do you guys do things at Cranbrook as well?
Yeah, so
Once a month.
yeah, the once a month star, try to open house, when we're actually in the field looking at stuff, is fourth Saturday. A meeting here once a month and a meeting in Cranbrook once a month.
All right.
And Cranbrook's our bigger one. East Cranbrook, and it tends to draw more people.
Yeah.
And we do 2 lectures, a short one, and then we break, and then we do the long one. Here, we just do the long one.
Oh, I never knew that.
Yep. Yeah, so next meeting.
Well, I know they had short and long, I just never added it, that this one never got the short
Yeah,
one.
we never do the short ones. Sometimes we'll do anthology talks, that's like 3 or 4 short talks.
Okay.
But, yeah, so I'm doing the short
When
talk
you
at
look at the
times.
telescope on the internet, we usually don't have
Let's go to Bay of Fun.
a human next to it,
Should
so
I-
you don't know how big the
Largest
thing
time.
is.
You can drive it.
And he said,
Where is it? Up in Canada.
Essentially east of Maine.
Yeah, we want to go to Maine. See that exact.
Sort of the armpit of it at the very end is in Brunswick there. Yeah, it's the largest tidal, difference. Interesting, I mean, like, take a photo, the boats are up here, and the next photo, the boats are basically on the dirt.
I started researching it because of the YouTube video, and I realized like low tides are Not what I thought they were. It is not more complicated, but more nuanced. Because if you just look at the little diagram, you don't get that stuff. There's all this extra stuff that is why, like, oh, this place has higher tides. Why would that place have higher tides than Florida?
Now that's interesting to figure out why. Yeah, I don't know.
Yeah, it's because tides are way more complicated than just, oh, the moon pulls on the water. They're an extremely difficult problem that many different things.
A lot of it has to do with the shape of the inlet.
Yes.
And the movement of the water, the timing.
Yeah, there's a whole thing called the
latitude and everything like that, tree. Yeah.
There's actual.
You're the right man for that. I'd like to get into that.
Yes, there's like a standing wave oscillation interpretation of tides. I can't remember what the phenomenon is called, but if you have like an island, like Madagascar or something.
Oh, yeah.
From your vantage point, it looks like the high tide goes around the island. It doesn't undulate like the east side of the island and the west side don't both get a high tide at the same time. It'll be high tide on the east side and low tide on the west side. Very strange, and not what you get from the simple little, oh, this is the moon pulls on the water.
It'd be fun to see how that influences Nazera, where they have the largest waves.
Yeah.
Portugal.
And how was that?
Tide.
It was
It's
fun.
that, the beats, those waves are something else.
Yeah, it's non-trivial that like the ancients figured out that the tides were linked to the moon, because that's also non-trivial. Like we can take it for granted now, it's not obvious. But then really starting to understand it, I mean, even you, like I said, you're in Florida measuring the times.
But flat earthers think the
And then
tides
you
come
think
from.
you understand it, but then you go over here and it's completely different. There's places that have 2 high tides a day. There are places that only have 1 high tide a day.
Really?
Yeah. And it's because that little model that they show you is drastically oversimplified. So
So when
it probably should have
Amazon
been more
Prime
talk, but I don't
yesterday,
mind.
they had that
So,
telescope.
I'm just giving the like
Teaser.
basically I saw a YouTube video that was not fear mongering, but talking about this big nodal alignment in 2034. And I
Doom and
want-
gloom.
Yeah, and I want to put you guys out ahead of it to tell you this is yes. Don't worry about the nodal alignment of 2034.
Oh, speaking of fear, or maybe it's not the right. Did you see that movie that the free showing?
No, I didn't. Good or bad?
I didn't see it.
Oh, okay. He told me it was good.
Okay.
Yeah,
Tongue in cheek?
No, I don't know. I didn't see it. He said the visuals were really good. They actually filmed at the Kennedy Center, and that it was done in good taste. They didn't smear NASA.
Okay.
That wasn't and I was really worried.
No booze were called for.
Yeah.
Okay, all right.
Yeah.
Okay.
I was very worried.
So much negative stuff up there, just clickbait, you know.
Yeah.
They got their lawyers, they got their money.
Well, and like, it was made by Apple, and they had that show For All Mankind where it was the Soviets got to the moon for the Americans, which I just, that's my baby. You don't get to rewrite history and have the Soviets in an American level. If you're gonna tell a fake story, you get your graphics guys to make their own spaceship. You don't get to use the Grumman flag and say it and put a Russian flag. I'm gonna call foul on that. You're not allowed. Not cool.
Think of Apollo.
I haven't seen it because I know I'll be way too triggered. Well, that's just a horror movie, right?
It's like a spider.
Yeah.
Well, they found capes in there. That's what made me provide it.
Okay, we're gonna get started.
So sunny, right?
Let me,
Yeah.
We all look alike.
One.
Okay.
That's Jack. Yeah, I know.
So, anyway, Bob Berta is gonna.
All you guys are talking to this.
Okay. So is the mic on this turned off?
Yeah, it's just going through this now.
Okay. So this is the microphone. Just hold it like
Oh,
this.
okay.
Okay.
Put it on my shirt or?
Yeah, your pocket.
Yeah, there we go.
Yeah, just a second. Okay, we're getting started again, you guys. Bob Berta has some pictures, I guess. 2 pictures he wants to show us.
Okay, oops, there we go.
I didn't get it very good.
Okay, okay, how do I get the stuff ahead? Get the stuff ahead on your, which, just share the screen, or what do I do here? Get on the one I had up there before.
You're asking me?
Uh,
Dale, how does he get pictures up here?
I had already brought them up once, so it's on the chip there, so. There you go. Okay. Okay. Highlight. Want to start with that one? Well, no, I'll do it. Okay. You do it with the mouse. Okay. These are a couple of pictures I took recently from my backyard in Macomb Township, which has about Bodal 5 to Bodal 6, maybe on a good day. The first one, let's see, make sure there's the right one here. Yeah. Okay, and then you go to here. Is that it? Okay. This is IC 405. And IC 405 is in Auriga. And this is a nebula that is known also as the Flaming Star Nebula. And this is not to be confused with the Flame, which is in Orion. And if you look at the, I think my mouse will show here, that's supposedly the flame. Some people say that's supposed to be the flame on a candle. But in any case, this light stuff up here is the smoke coming off the candle. And so I thought that was an interesting picture.
Bob,
yes.
where were you when you took that picture?
My backyard, 25 Mile Road and Romeo Plank.
Where there's tons of light pollution.
Yeah, tons of light pollution. This was taken, both these pictures I have you were taken with my 8-inch Schmidt Cassegrain with a hyperstar on it. And a hyperstar device that bolts onto the front of the secondary in place of your normal secondary corrector.
Put it in the chat, don't break in.
Yeah, somebody's in the background. But specific to
Bob, we don't see it on the.
Somebody on top.
Oh, it's not being shared. Oh, you're not sharing it.
Oh, okay.
I might be able to figure it out.
That's all right.
Not that one.
This one down here?
Yeah.
I want the Zoom, don't I? Where's the?
It's the web browser. He's got it in the browser.
Is that this?
Yeah.
Okay.
Share screen.
Help me, Dale.
Oh, on the bottom.
More. Oh.
There you go.
Just entire screen or? No. You got it now?
Yeah, it's come through now.
Switch it back there. Yeah.
Okay, there you go. Okay, let's go back where we were. A little technical difficulty there. This telescope, what it allows you to do, instead of taking an image, at the native either f10 or f7 with a focal reducer, this reduces it down to f1.8 to f2. Makes it very fast. It's about 10 times faster than if you had taken it at f7. So a minute exposure would be 10-minute exposure with a normal telescope. It also gives you a wide field of view. Also on this, I used a dual narrowband filter. That's the thing to use now if you live in light polluted areas. It allows you to get pictures in pretty strong light pollution. I did this about 2 days before 4th of July. So the moon was up and pretty bright, and where I live is pretty bright. Okay.
What do you mean by a dual band filter?
Dual band is a filter that has coatings on it, which isolate and let only the light pass through in 2 frequencies. One is H alpha, which is what, 830 something, 650. Okay, 650 nanoseconds, and then the other one is for oxygen 3, which is a lower down. It gets about four or so.
I don't know the number.
Yeah, I don't remember the number.
This is star forming nebula.
Yeah, this is a star forming nebula, and this is what you would use for an emission nebula. Okay, that's pretty much all I wanted to talk about that one predictor picture. By the way, that is about 37 by 39 arc minutes. So that's about the size, this is slightly bigger than the size of the moon. Okay, the other one I want to show is this picture. Let's see if I can switch over to that one. How do I get to that one?
You can just exit this one off and then
Exit that one, get off of there, exit off.
yeah.
Okay.
And then minimize this.
I think just go down to your,
Click on the folder.
your little yellow folder there in the bottom center.
Go to the folder.
There. Okay, there we go. Okay. This other one, which I think is a really cool one, and I never even really thought about going for this one before. This is a nebula, and I'll tell you what it is and it's not is in a second. It's part of the Sharpless catalog. There's a fellow who created a catalog of all tons of really cool nebulas, mission nebulas, called Sharpless. And Sharpless 2 has many of these. This particular one is number 174. And the thing that's neat about this is very, very close to the North Star, Polaris. So it's very easy to see. In fact, it's the closest nebula, or second closest nebula to the North Star. And later on, I'll show you actually where it is on a map. The thing that's neat about this, it was discovered by Sharpless in 1959. And originally, everybody thought it was a planetary nebula. But they started looking at it, and a lot of famous astronomers said, yeah, probably is. So they said, well, let's give it a number. So they gave it a planetary nebula number. Well, lo and behold, they started finding out in 2008, an Australian doctoral student looked at the thing and said, you know, it doesn't make sense because the way a planetary nebula like that is created is by a star dying, going supernova, whatever, and said, you look at the speed of the nebula itself versus that star, they're going at completely different speeds. In fact, not only are they different speeds, they're about several million years difference, or billions of years, I guess, in that difference between the age of those two objects. So they say it's probably just by chance they ended up being there. The thing that's cool about this, as the first picture I've taken with my same setup, it actually shows the blue and red right on the original image right there. I didn't have to do any filling to get the blue to come out or anything. It's pretty amazing. It's called the Valentine's Rose Nebula. It's in Cepheus. And again, you all know about the rose, right? The rose, famous, gorgeous picture. Well, this is not that rose. This is a different one. Let's see now if I can think of anything else here. Okay, as I mentioned, this also, one reason they don't think this is a planetary nebula is by a few other things. One is, normally most planetary nebulas have a circular shape, you know, as the star blows up and it pushes out in a circular shape. Well, it doesn't really have that. It doesn't have a outer edge that's brighter than the inner part, because generally when those stars blow up, the inner part is dimmer than the outer part, because the outer part is brighter because of that explosion.
That looks a bit larger than many.
It is, yeah, it's pretty good size. It is, in fact, let's see if I think I even have the dimensions on here. I think if I can find I've got it written in here somewhere. I have to look for it in a little bit. But rather than keeping you tied up, I'll just look for it later. But it's interesting because not only the thing I mentioned about the nebula not fitting in the mold of what a planetary nebula is, and the thing about the star at a different speed, different age than around it. So they really don't know what it is, something unusual. Well, that was neat because, again, this was taken from my backyard. This was when the sky was pretty well lit by the the street lights, the moonlight, etc. So I was surprised I got that. So again, these narrowband filters allow you to take pictures in really bad light pollution. There are people who go right in towns like Los Angeles, right from their backyard, able to get pictures like this, which is astounds me. Okay, that's pretty much it. Oh, one thing I want to show you.
What was the exposure time?
Both were relatively short a number of times. This one was 3 minutes. One was 3 minutes each exposure, and about a total of an hour's worth of 3-minute exposures, which is phenomenal. Basically, you had 3 minutes in an hour. So if you took that ratio of the 1.8 to the f7, which a normal SCT would be at with a focal reducer, that'd be the same thing as taking, instead of a 3-minute long exposure, a 30-minute long exposure. The other one I took was 5-minute exposures, which actually was probably a little bit too long, but a 5-minute exposure would be like equivalent of a 15-minute long exposure through a regular telescope. So again, makes you be able to get really dim things very quickly. So I really like the Hyperstar setups. Hey, one last picture I'll show you real quick. And I think it's this one right here. Okay, and what this is a screenshot off of Sky Safari. And this little circle right here, small one, that's the sharpless Sharp 2 174. If you look at this big circle here, that's another sharpless object. That's huge. Down here where my cursor is here, that rectangle is about, I think about 3.5, 4 degree field of view. That is what the field of view of my camera is. So my camera, even with the wide field, it's still not big enough to capture this whole thing. But this is every sharpless object in this area, all the little gold things. You can go in Sky Safari, look for a catalog, and actually bring it up and mark those on screen. So all those gold things are sharpless objects. So that will keep me busy for quite a while. I don't know exactly how many there are, but I think there's about 200 objects of the Sharplet catalog. So I'm going to go back and do some longer ones. That last one I showed you, that was a really cool picture. I want to get some more detail on that. It's pretty neat. Okay, that's it. I don't want to tie everybody up. I know Dale wants to talk, but anybody have any questions about that? You could probably talk to me after the meeting if you have any more stuff.
Okay, thank you, Bob.
Okay. And let me see if I can get it out of here. I'll just go ahead and unplug it.
Yank it.
Okay.
Bob?
Yes.
Are you good to microphone?
Yeah.
Oh,
No.
yep. Sorry about it. Here.
Find my presentation on here.
Oh. And then you have to click this to your persons. Should I introduce you as you?
Let me make sure everybody can see it.
Does he introduce himself?
No, bylaws won't allow it.
Okay, go ahead.
So Bob's our president. He's not here. Our first vice president, Dale, usually introduces our speakers, but we're going down the line. So now I'm first vice president. It should be Riyadh.
Just hold it.
All right. So do you prefer doctor or professor? I usually call you professor. Is that wrong? Doctor. Dr. Partin has been a member of this organization since 1998. He's been an officer for I think as long as I've been a member of the club. I think you've been on the board. He's one of the most credentialed presenters you're going to get out of this club. He has had a career in industrial research with 38 U.S. patents and over 80 publications in scientific journals. Worked for GM
Research Lab.
GM Research Lab, did some really cool stuff. He now teaches not at this location, but at Macomb Center Campus to the north. And his topic tonight is astronomy from the moon, which I'm very interested in.
Thank you. Yeah, I teach introductory astronomy classes here at Macomb. Okay, I assume the people who are online can see my title slide.
We see it.
I forgot. Just 1 second, please. Oh, I can't use this because they wouldn't see the laser beam.
Use the mouse.
Yeah. Okay. Astronomy from the moon is the topic. Here's a picture of one little piece of the moon. And to look at it, you wouldn't think this would be valuable real estate, right? I mean, it was described by one of the early Apollo astronauts as a magnificent desolation. That might have been Apollo 11.
Yeah.
Was it Buzz Aldrin that said that?
I think Aldrin said that.
Yeah. And it looks fairly accurate. You know, what would be the good of trying to do astronomy from such a place, right? So I'm going to talk about radio telescopes, why you might want to use them on the moon, then infrared, then ultraviolet briefly, and then gravitational wave astronomy from the moon. So let's start from a more down-to-earth perspective. Sorry, I have to chew gum when I give a lecture or my throat goes dry. I apologize.
One moment. Where's the presenter view online instead of that view? Jeff, you know how to?
We can try to just change what's being shared.
Now we're sharing you.
Well, that's what I want. Where to go?
Is that what you're looking for? That little thing there?
But do you want the presenter's notes?
No, there are no presenter's notes.
Well, I stopped sharing was the problem. All right, Dale, which one's the Zoom? The browser? Okay.
It's in the browser, yeah.
Share screen. Share screen 2. Ooh, yeah. Share.
There we go.
Okay, now where's his presentation? PowerPoint.
Okay, that's fine. I can work with that.
Make sure it keeps going.
Let's see. The down arrow key does not do anything.
Oh, it's the right arrow key.
Right arrow key? Okay. Okay, so let me figure out where I was here.
The left arrow key. Back. There you go.
Okay. So if you want to do astronomy the way we normally do it from down here on the ground on planet Earth, you have to ask what wavelength is accessible. What wavelengths of radiation can make it down through the Earth's atmosphere so we can see it, either see it with our eyes or with our instruments. And the answer is mostly you can't do astronomy at most wavelengths from down here on the Earth. This is over here is long wavelengths. That means radio waves. And then infrared. And then
you want to look at the other monitor because your cursor is not going to show up on the small one. You're going to have to move it over to try to get it onto, because that's what they're seeing.
how in the world do I get my?
Yeah, you should be able to just track over to the other monitor. I just don't know if it'll be left or right or up or down. Yeah, there you go. So just look there.
Okay. I hope I can get my computer. I hope I can get my computer back after we're done so it works for my normal stuff, you know. My goodness, this is more complicated than doing astronomy. Okay, so this is wavelength along this axis from very long wavelengths like 1,000 kilometers and up. Radio waves. Right in here, some places, microwaves, which is really just shorter wavelength radio waves. Then infrared. This tiny little sliver that our eyes can see and where the air happens to be pretty transparent, called visible light. Then ultraviolet, just a sliver of ultraviolet makes it down to the ground, fortunately, or we'd all have skin cancer and cataracts on our eyes. So most ultraviolet, the atmosphere is opaque to, then X-rays, then gamma rays. So this is why, if you want to do astronomy with and look at gamma rays or X-rays or ultraviolet, you normally put a satellite up in space with a telescope on it. Similarly with infrared, there's a little bit of transparency to short wavelength infrared, especially if you go up on a high mountain. Radio telescopes on the ground are in this wavelength range. Although even in this wavelength range, all is not wonderful. The ionosphere high up in our atmosphere causes problems with radio waves coming down through. But you can do radio astronomy if you're careful. Okay. So we haven't got to the moon yet, but just make sure we're all on the same page. This is the largest single antenna or single dish radio telescope in the world in China. It has a 1 kilometer diameter. We had a pretty big one in Puerto Rico called Arecibo. Anybody remember how big that one was? It was, I don't know, maybe half as big as this one. Might have been 300 meters across. So this one is way outclassed it, and the one in the Arecibo one in Puerto Rico is gone. So this is a fairly impressive instrument in China. There's an antenna that you can't see up above that dish antenna collecting the radio signals, which are amplified, stored in computers, and converted into images or whatever. If you want to go bigger than that, we've got one way bigger than that, called the Very Large Array out in New Mexico. It's an array of 27 radio telescopes, but they can be all put close together like this, in which case they act kind of like, if you combine the signals detected by all those radio telescopes looking at the same object, it kind of acts like one big radio telescope with a diameter like this. And then you can put these dishes on railroad tracks that you see here and spread them way out to where they act like a radio telescope with a diameter of 36 kilometers. You don't get the sensitivity that you would get. You don't collect as much energy as you would with a single dish, 36 kilometers in size, but you get the resolution. In general, the bigger the telescope, the finer the details you can see with it, whether you're talking about an optical telescope or radio telescope, assuming the atmosphere isn't degrading your resolution. So that's a US facility. The biggest is the Event Horizon Telescope, where they take some large radio telescopes in various places on one half of the Earth. You can see here. They all look at the same object at the same time. And the resolution is basically the size, based on an antenna, the size of the Earth. And that's how a black hole was first imaged. So much for radio astronomy from the Earth. The problem with doing radio astronomy like this is we've got cell phones emitting radio waves. We've got AM radio blasting away, FM radio blasting away. We've got military communications, other government communications. We've got satellites sending radio signals between each other and down to the Earth. We're immersed in radio noise. It's terrible to try to do radio astronomy from the Earth. It's amazing they do as well as they do, but they're fighting like crazy. I mean, Bob just showed us some amazing images done in the midst of huge amount of optical noise from street lights and the moon. Under certain conditions, you can get away with that, but it makes it really tough to do radio astronomy. So that's why the moon becomes attractive. Here is the Earth blazing away with all kind of radio communications, much of which leaks out into space in all directions. And here's the moon. And on the far side of the moon, you've got 2,000 kilometers of moon blocking those signals. So the far side of the moon is a radio quiet zone. Some people refer to the far side of the moon as the dark side of the moon, which is wrong. You know, the far side of the moon is fully illuminated by the sun half the time, just like the side we see is fully illuminated by the sun half the time. But from a radio signal perspective, it is the dark side of the moon. There aren't bright radio signals hitting it at all frequencies. So that makes the far side of the moon a potentially attractive place for radio astronomers to do work. Arthur C. Clarke, I just learned, in 1963, predicted that radio astronomy, as soon as the ability to do so was there, would move their telescopes or set up telescopes on the far side of the moon. I mean, he said that in the midst of Kennedy saying we're going to go to the moon, and people thought a lot of people are going to go to the moon and all of that, till that all fizzled around 1973 or so. So that's for radio astronomy. There's a motivation. The only artificial radio signals you would expect to see on the far side of the moon are stuff going back and forth to like spacecraft, like the Juno spacecraft going around Jupiter right now, is sending back stuff, and other satellites that are out there beyond the moon. But at least they're a long way off, right? If they're out by Jupiter, that's a lot farther than the Earth, and a much more limited set of frequencies coming in.
How would you get the signal through back to us from the other side?
Did somebody ask? I couldn't make out. What was that? Was that a question?
Yeah, well, how would you get the signal back to the Earth from the other side?
Good question. How would you get the signal back? Yeah, you'd have a satellite relay. So at a frequency that you're not interested in, you would send a signal up to a satellite, probably at the L2 point above the moon, and then from there radio a signal back. That's what the Chinese are doing right now. They have a satellite orbiting above the far side of the moon, and their rover down on the surface sends signals up to that and back to the Earth. And did you have a question?
Yeah, the sun, it does put out radio signals.
Yes.
Doesn't it?
Yeah.
But apparently not enough to interfere with a telescope on the moon. Like the Earth would interfere with all of our radio communications.
Jupiter sends out radio signals too.
So it still gets
I mean, not satellites orbiting Jupiter. I mean, Jupiter itself does. but that's way down from us blasting away at all over the radio spectrum. Okay. Here is a chart. It's the United States frequency allocations of the radio spectrum. There's so much detail here. I put this on my computer screen with my book reading spectacles on and a magnifying glass. I'm not exaggerating. Trying to read this, and to my best ability, well, let me tell you what it is. Let's see. This starts, I wish, where did I put my glasses? That pair. Thank you. Yeah. The top line starts at 30, where am I? I lost my cursor. Here it is. Over here is 30 kilohertz radio frequency. And it goes across this way to 300 kilohertz. So that's a factor of 10 increase in frequency. So 300 kilohertz is over here again, and then it goes up to 3 megahertz. So it's a factor of 10 across every time you go down. And the last band here is up to 300 gigahertz at 3 billion cycles per second. You're almost up to infrared at that point. Here is AM radio right here in this big blue band. And FM radio, I can't read it, but it's one of these bands here. And there's AM, there's amateur radio, there's stuff used for GPS signals, the military stuff, you name it. Everybody's got a piece of this pie, and they fight over it all the time. So over here is a color chart that tells you what each color, who owns that piece of the spectrum. And this is for radio astronomy that I circled right over here. And so I went through this chart with a magnifying glass, and these red arrows point to pieces of spectrum reserved for radio astronomy. Some of them, like this one here, it's shared with something else. I don't know how that works, but there's two owners of that piece of the spectrum right there. So you could, if you're trying to do radio astronomy, you can pick any one of these little slices and, you know, tune your radio antenna to receive that signal, point at the thing you want to study, collect data. The problem is the Doppler effect. What if the thing you want to study is moving away from you, which a lot of stuff is, right? Or coming toward you for that matter. So I illustrate that here. Suppose you want to study a cloud of hydrogen gas. There's a lot of that up there floating around, left over from the Big Bang. So one of the frequencies given off by hydrogen gas is here, corresponding to a wavelength of 21 centimeters. Okay? That corresponds, this is for neutral hydrogen atoms, 1 electron, 1 proton. A proton has spin, and so does an electron. And so it can either be, each of them can either be spin up or spin down, according to quantum mechanics. So if they're both spin up, those spins interact with each other from an energy perspective. And if the electron spin flips to down, that's a lower energy state. So it gives off energy, a photon of light or radiation, with a wavelength of 21 centimeters. That's very well known for hydrogen. there are radio astronomers today trying to use that spin flip energy to study neutral hydrogen way back close to the Big Bang, right after recombination, it's called. Originally, the Big Bang was so hot that you couldn't have a neutral hydrogen atom because the electron would get knocked off from the atom by a high energy collision rapidly. But when the universe cooled down to, I think, about 3,000 degrees Kelvin, electrons could combine with a proton to make neutral hydrogen, and it was stable. So people are trying to do radio astronomy to study the distribution of that across the sky, that kind of stuff, using this wavelength. But that stuff is redshifted, okay? Especially if you're trying to look right after the Big Bang, it's super redshifted. But even if you're trying to look at stuff a couple galaxies over, it's redshifted. So the 21 centimeter wavelength, it might be over here, redshifted to this wavelength or this wavelength. Oops. Well, so if the thing is moving away from us, here's the normal frequency or wavelength. If the thing is moving away from you, it's shifted out to longer wavelength. And you're getting interference from all this other stuff, right? That's why you want to go to the moon and put radio telescopes on the far side of the moon. Yeah, Bob.
What is the blue arrow on the second line?
That's another band reserved for radio astronomy, and that's where the 21 centimeter line is.
Why
So
blue?
I just picked blue to point it out. That's where it is on this.
Specifically hydrogen 21 centimeter.
Yes,
Yeah, okay.
that's it. But it could be red shifted way down here, even to the next band up. You know, I mean, even beyond that, because you're looking way out there, the red shift is like 1,000. You know, I mean, it could be anywhere on this chart at lower frequencies. So it's miserable to study that stuff if you're trying to do radio astronomy from the Earth. So, okay, so suppose we put it on the far side of the moon, a radio telescope. You might, you know, here it is. Well, how would you build it? People are talking about laying out metallic parts of the antenna like this, an automated system. Maybe put one like 10-meter kind of size, and then somewhere else on the moon put a bunch of these in different places. So you can make something like an event horizon telescope on the moon. Okay? So you can get higher resolution.
Does it need to have that parabola dish shape?
Well, you can get that, right? You can put a shape to these if you put them under tension. Depending on the wavelength you're working at.
So little gravity, it doesn't need much structure.
Right,
for it.
right.
There's no wind or even
There's no wind.
mess it up.
And what can you do? I mean, this is a picture taken with, I think it's called ALMA. It's short wavelength radio waves or microwaves. Looking at a star that's not too far away, what you're seeing is dust, okay, in a newly forming star system that was a rotating disk of dust and debris. And planets are starting to come together. And every place you see a dark ring, that's where a planet is going. A new planet is collecting all the stuff in its orbit, okay? This is a false color image, which is what you always see with this kind of stuff. You're not looking at visible wavelengths of radiation coming in. So if you made a diagram in the actual wavelengths they were collecting, you couldn't see a thing, right? Your eye can't see that color. So false doesn't mean deceptive. It means they just take the frequencies and convert it to a color your eye can see. Another thing you can do, I thought this was kind of slick. You could potentially look for exoplanets with such radio telescopes, especially big ones where you got real good resolution. What you would see is not the planet itself, but if the planet has a magnetic field, like the Earth does and Jupiter and Saturn, that magnetic field is called the magnetosphere of the planet. And the solar wind, in this case, or the solar wind equivalent of whatever star this planet is orbiting, is coming in from the left, and it kind of pushes the magnetosphere out to the right. Okay? Jupiter's magnetosphere, Jupiter has like 20,000 times stronger magnetic field than the Earth does. The magnetosphere of Jupiter is blown out away from the sun so far that the tail of Jupiter's magnetosphere goes out to the orbit of Saturn. And it's like 6 degrees on the sky. It's enormous. So you can image this with a radio telescope. The reason is these trap electrons, these magnetic fields, and the electrons, it's kind of a physics thing, but they spiral around these magnetic field lines. And when the electrons do this spiraling, they send out their own radio waves. Okay? So you can image that stuff and image the magnetosphere of a planet. That means you know there's a planet there, so you potentially just discovered a planet. And you know it has a magnetic field, which means its atmosphere, whatever atmosphere it has, is protected from its star's solar wind. This is why we can breathe here on Earth, because the Earth has a magnetic field, and the solar wind has not knocked our atmosphere away from Earth over billions of years, like it did to Mars. Because Mars, being a smaller planet, cooled off a lot faster than the Earth, and it lost its magnetic field when things solidified down in its core, which means, I mean, we know it used to have a thick atmosphere because there used to be liquid water on its surface. You can still see dry river beds and all that kind of stuff. So Mars lost essentially all of its atmosphere because it has no magnetic field. So if you see a magnetosphere from a planet, there's a possibility, a likelihood, that it has a thick atmosphere. And if it has a thick atmosphere, it might be, and you study it, you might find indications of living stuff, like oxygen or something, right? Not necessarily intelligent life, but primitive life. So that's something you might hope to do with radio telescopes if you can get rid of all the interference that we have here on the Earth.
So Dale, you're saying you can't actually see the planet, but you can get the image of the...
Its magnetic field, its magnetosphere.
Right. That would indicate the presence of the
You could potentially image the planet.
Yes, you could potentially image the planet too.
The resolution scale wouldn't be that good, though.
You don't need, but at least imaging the magnetosphere is a lot bigger than the planet, right? So you may be able to image the planet too if it's a big one and putting out a lot of stuff like Jupiter does. But even if you can image the planet, it helps to also be able to image the magnetosphere if it has one, because that tells you there's a magnetic field in the planet, which is a good thing for the prospects of life. Okay, that's as much as I'm going to say about radio telescopes. Not quite. One other, I'll say more later about that. Let's talk next about infrared telescopes on the moon. Infrared telescopes, like the James Webb scope in the lower left, have to operate very cold. If they're hot, they give off, the hot parts of the telescope give off infrared light and fog the images you get, so to speak. So the Webb telescope has this complicated, many-layered solar shade under it, between it and the sun, to let it cool down. It operates at a temperature of about 45 degrees Kelvin, or minus 380 Fahrenheit. That's what you need if you want to have an infrared telescope, especially one that can go out fairly far into the infrared, not just barely into the infrared. So you need cold operating temperatures. So one thing that you could do to get cold for free would be to go to the south pole of the moon, where there's some craters that never see sunlight. They're typically a few kilometers deep. And so there's a lot of interest in those craters because it appears that at least some of them have a lot of ice, water ice condensed down in them, probably from comets going by over billions of years. And stuff from the comets, one of the main constituents is water vapor coming out of them in their tails. So if some of that happens to hit the moon at its south pole, it freezes when it goes down in these cold craters. Same thing, by the way, on the planet Mercury. It has craters near its pole, and you can see evidence of water on Mercury near its poles in these craters because it's cold. So there's a lot of interest in putting bases near the south pole of the moon next to these craters. The axis of the Earth is tilted to the direction of the ecliptic plane by 23.5 degrees. That's why we have seasons. The moon's axis is only tilted about 1.5 degrees. So you don't have seasons on the moon. So sunlight can be hitting up at the top of these craters more or less year-round, but never down in the bottom of them if they're real close to the South Pole. That means if you put an infrared telescope, I just grabbed a picture of any kind of telescope as a symbol of a telescope. If you put one of those deep down in the crater, it's going to be cold. And you can put solar cells up on top of the crater to get energy to operate the telescope.
Would this also be applicable to the North Pole of the moon?
Yes. I think it's a more rich environment of craters at the South Pole.
That rim would really limit your field of view, right?
Yes. Yes, it
It's like
does.
looking through a stovepipe.
Well, it's a fairly large field of view, but you're only going to be able to look to the south, roughly speaking. You're never going to be able to look, in strongly different directions. That's true. You don't have to put a telescope here, but that's one option. And radio telescopes like it if their receiver is cold. And I just learned that NASA is funding a mission to send a small spacecraft to this area of the moon to assess some things for radio astronomy. I guess I should have mentioned this when I was talking about radio astronomy, but the problem is it really radio quiet at the South Pole down in all these craters? Because even though there's no direct line of sight to the Earth, radio waves, like any kind of waves, can diffract around the edge of the crater, and some of the energy will go down into the crater. So there's a spacecraft, a small spacecraft that's NASA's funding somebody to work on, that's going to land somewhere around the South Pole and do some assessments of that. How radio quiet is it? Up to, I think, 30 megahertz they're going to look at. And also they want to examine the radio characteristics of the lunar soil, because that matters to a radio telescope. The soil that's under a radio telescope here on Earth affects the performance, because there's coupling, electrical coupling, between the antenna of the radio telescope and the ground. And if it rains and the ground gets wet, that changes things a lot. You don't have to worry about rain on the moon, right? So that's going to be happening.
So for a radio telescope, that even when, let's say, even the far side of the moon was exposed to the sun for half its day, half the month, it can still, radio telescopes can still work in broad daylight.
Yes, radio telescopes work in broad daylight. It's better for them if they're cool.
Oh,
Yeah,
the light doesn't bother them, just the heat radiation.
right.
Okay.
But they work. You can do radio astronomy from the Earth 24/7. You can even do it through clouds. Not as well, but you can do it. So I just threw this out. You know, if you want to do infrared astronomy, you can get pictures like this, taken with the James Webb. I'm pressed for time, so I'm going to keep going. Comparing lunar versus space-based infrared telescopes. One of the problems with putting telescopes on satellites is how do you point them at the thing you want them to point at, and then they'll stay pointed at that thing. They use what's called reaction wheels. These are sort of like things that can rotate, right? And if you rotate the reaction wheel this way, the telescope goes the other way because of conservation of angular momentum, right? Good old mechanical engineering kind of stuff, or mechanics and physics. But those moving parts wear out. Like the Kepler telescope worked for, I forget how many years, 3, 4 years. It had 6 reaction wheels on it, so it had 3 spares. You need 3 different axes of rotation. But it got to where I think only 1 or 2 of them are still working. So in a kind of a very limited mode of operation right now, playing all kind of games. With that, what?
Hubble's lost a bunch of.
Yeah, they're now down to 1 reaction wheel.
They could replace them on the Hubble.
They can if we ever send another mission up there to do it. They already replaced them once.
Yeah.
And they didn't just put 3 up there. They put maybe a half a dozen. And I just read they're operating on 1 right now. And it's very dicey to make it work. SpaceX was talking to NASA about setting up a mission with astronauts to put new reaction wheels on, but NASA didn't go for it because of the propellants that SpaceX used. They would prefer a hydrogen-oxygen rocket. So there's no possibility of organic contamination on this telescope mirror. And the National Reconnaissance Office gave NASA 2 new optics that are better than the Hubble optics. So they're going to build a new space telescope. What is it called? I forget the name of it. It's supposed to launch by 2027, so fairly soon. These National Reconnaissance Office optics are what they no doubt use for their spy satellites looking down at the Earth. And they have a much wider field of view than what the Hubble has. They can see, it's either 50 or 100 times bigger area in one picture than the Hubble telescope can. Yeah, it has a very short focal length. So they're building I guess they don't say it's a replacement for Hubble, but it'll be the same size, 2.4 meters, and cover pretty much the same wavelength range from the near UV out to little ways into the infrared. How did I get on that? Anyhow, yes, the Hubble is down to 1 reaction wheel. Also, a lunar telescope. So on the moon, you don't have any reaction wheels. You've got the moon You just anchor yourself to the moon and you move to where you want, and that's where you stay. Other than the moon slowly wobbling around, but that's real slow. And also you have no solar panels sticking out that if they start vibrating, that throws off your pointing accuracy. That also was a problem for the Hubble early on, and they had to fix that somehow. You can have the solar cells attached to the ground separate from the telescope on the moon.
Would you still need essentially a German equatorial mount?
You need some kind of mount, sure, to point at what you want to look at. Yes.
The radio telescopes you have here on Earth don't.
Right. They can effectively move the thing that collects the radio.
Okay.
The dish can stay fixed within some limit, and the thing that they can steer them.
Okay.
I mean,
it's limited in the.
It's limited.
Angle.
Like that Chinese telescope I showed you, the dish doesn't move at all, but the thing that collects the signals can be moved around. Okay. That's what Arecibo used to do. But the very large array, those dishes can point wherever they wanted to point. So for a lunar telescope, you can put them in a crater at the South Pole or anywhere on the far side of the moon and take advantage of the long lunar night, which is about 2 weeks long. But then you have the long lunar day, right? In terms of servicing a telescope, here's a diagram of the sun, the earth, and James Webb is making this loop. That's because ideally they'd be right at the L2 point, which is gravitationally stable, but I did a back of the envelope calculation. The earth would almost perfectly cover the sun from that point, okay? So your solar cells wouldn't collect any light. So to fix that, they have this orbiting this L2 point, which slowly uses up fuel to keep it in that, because it's not quite as stable as if it was right at the L2 point. Latest estimate I saw was they think they got enough fuel for 20 years, though. So in terms of servicing, right now we don't have a way to service the Webb telescope if it needed it. It's a long way it's about 1 million miles from the Earth. If we have a base near the South Pole on the moon, which is the plan, and the telescope is nearby, you can service it. I'm going to very briefly talk about ultraviolet telescopes. Almost all ultraviolet is blocked by the Earth's atmosphere. That was in the earlier diagram I showed you. NASA had a telescope launched around 1999. It operated for a few years until its reaction wheels stopped working. Everything else was working just great, but not the reaction wheels. The Hubble telescope has a limited UV capability. Doesn't go very far into the UV. And like I said, it's currently operating with one reaction wheel. So you keep hearing, I'm talking about reaction wheels because on the moon, you don't have them. So a good place to put a UV telescope on the moon would be in a permanently shadowed crater at the South Pole. Why? Because there's no dust there. The problem is if you're out where on the surface, when the sun is shining and the solar wind is hitting the surface of the moon, electric charge builds up on the surface of the moon and it levitates dust particles, and they can get on your optics. People are still using the mirrors left on the moon by 3 of the Apollo missions to measure the distance from the Earth to the moon. Now that distance can be measured to plus or minus 1 millimeter. which is phenomenal. Back in the 70s, they could do that measurement to plus or minus about 2 centimeters. But the electronics and lasers and stuff are so much better now that it's down to plus or minus 1 millimeter. But they've also determined that the mirrors that those laser signals bounce off of on the moon are about 50% covered with dust. Now, it's been a long time, right? What, 50 years or whatever? But it is an issue. So that only happens if the solar wind has a direct line of sight to the part of the moon you're operating in. So if you're in one of those shadowed places, it's not that much of a problem. Presumably, you could clean the optics once a year. Just puffs of nitrogen gas or something would probably fix the problem if you're out somewhere else on the moon. And if you put multiple UV telescopes together and you could do interferometry with them, like in the radio wavelengths with the very large array that I showed you, you could get super high angular resolution. You could potentially image planets in the UV and image their atmosphere when they do go through a transit of their star and see if there's oxygen in the atmosphere. It's hard to detect oxygen in the atmosphere of another planet using visible and infrared. Oxygen just doesn't have strong absorption and emission lines in those wavelengths, but it does in the ultraviolet. That's what causes our ozone layer that's absorbing ultraviolet light from the sun and protecting us. So the last topic I'm going to talk about is doing gravitational wave detection from the moon. There are currently 4 gravitational wave detectors on Earth, one in Louisiana, one out in Washington State, Italy, and Japan. They operate together to form one observatory. The European Space Agency is also working on a detector called LISA that will be put into space. It'll have like 1 million kilometers length between mirror and lasers, forming a triangle. I think it'll be at least a decade before it goes up. But that would let them look at way lower gravitational wave frequencies because the baseline is so long. So if you have 2 black holes or 2 neutron stars or a black hole and a neutron star orbiting each other, as they orbit, they give off gravitational waves. And as they get real close, those waves get stronger and they go around faster until they merge and you get a big pulse coming out. That's a pulse not of electromagnetic radiation. It's a pulse of gravitational energy going out. And if such a pulse goes through this room, it changes space. Okay, it stretches space, you might say. So we would stretch as the ripple goes through us, but it's real tiny effect. Super tiny. These observatories for gravitational waves, if an atom is this big, the nucleus of an atom is 10,000 times smaller. And their sensitivity to detecting these gravitational waves is 10,000 times smaller than the nucleus of an atom. 10,000 times smaller than a proton. Okay? That's what you have to do to detect these waves. I thought this is a neat picture. It shows a neutron star just in the moment it's being sucked into a black hole. They saw such an event and simulated what it must have looked like if you could see it. And this is one of the images from that simulation. So Why would you do this on the moon? The Earth is not that stable. I read that the detector out in Louisiana, if a truck goes by 10 miles away on the highway, that affects, they're sensing the vibration from that. It's messing them up. And the Earth itself is always having very minor earthquakes, you know, on the Richter scale maybe a 2, right? Not even worth thinking about, but it affects them. So on the moon, a similar gravitational wave detector could detect 100 times lower frequencies, where a lot of this rumble is in the Earth. So if they could do that, they could see if, for example, if you have 2 black holes, when they're pretty far apart, that's a low frequency signal that we normally can't detect here on the Earth. Only as in the last second or so, as they come in radiating away gravitational waves, just before they do that, that's when we can detect them. If you catch them when they're going 100 times slower, you would know it was coming, you could see it coming, and you could have other kind of telescopes look at that region of the sky and see if you can see anything happen, right? The ultimate discovery people talk about, if you can go out to lower frequency detection, would be to detect the rumble of the Big Bang. So on the moon, being cold is good for these kind of detectors. Low thermal vibration of the mirrors and so forth. You could build one that formed an equilateral triangle. It's always dark, so there's no dust. Dust particles going through the laser beam would cause noise. That would be bad. Here on the Earth, you put these laser beams inside of big tubes that have ultra-high vacuum in them. You wouldn't need the tubes, that you could be out in the open on the moon. Use the vacuum the moon provides. This is an image of the south polar region of the moon. So I put a big red X right at the South Pole. That's right on the edge of this Shackleton crater. I think Shackleton was one of the early explorers that went to the South Pole of the Earth. Did he make it there? Did he claim he made it there? Okay.
Ship froze in the water.
Anyhow, crater's named after him. And I think Amundsen, wasn't he a guy that tried to go to the South Pole too?
He made it.
He made it? Well, he didn't quite make it here. Shackleton. So, and here's a crater named Schumacher. I assume that's the Schumacher-Levy that we all have heard about. Anyhow, there have been various spacecraft that have flown over these regions on the moon, measuring different things, trying to sense, is there ice down there? How much ice is down there? What's the temperature down there? Using various instruments. Shackleton, they see a lot of evidence for water ice, same with Schumacher. For some reason, Faustini, there's contradictory evidence, but could be that there's not much water down there. And that would be good for if you want to put these kind of telescopes down there, because that means other people aren't trying to go down there and mine for ice. Okay. So Faustini might turn out to be a place where they try to put some of this stuff. I blew it up. This is a temperature scale, by the way. These colors, that's not illumination from the sun, although it kind of tracks with that. It tells you the temperature of these various places. So I just sketched out an equilateral triangle down in this Faustini crater. And then people are starting to say maybe there's a different kind of gravitational wave detector you could put on the moon, and that uses the moon itself to do the vibrating. And you put ultra-sensitive seismometers all over the place. And you could sense, the moon changing size or shape as a gravitational wave rippled through it. I don't know whether the sensors we can get would be good enough to do that, but maybe. This is my last slide. International agreements to protect the moon would be very helpful. Need to agree on what radio frequencies will be used on or above the far side of the moon. So if everybody agrees, that we'll only use these frequencies, that would leave most of it open for astronomy. And you need agreements on protecting the moon seismically. If you're going to have big Earth moving equipment going down around in these craters, going boom, 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 that would be not so good.
There's moon moving, not Earth moving.
Yeah. Moon moving equipment. Yes, not Earth moving equipment. Okay, so that was my presentation. I'm open for questions. If anybody has some. Same thing online. If anybody has a question. Anything coming through, Dale? Okay, well, actually made it through it in a reasonable time, a little under an hour. So let me see. Is there anything else I needed to announce? Our next regular meeting will be Monday, August the 6th at Cranbrook. Next Star Party at Stargate will be Saturday, July 27th. And anybody that wants to go out to the restaurant, welcome to come. It's where? At the corner of 12 Mile and Groesbeck. Good night, everybody. Let me see if I can get